Alright, hello guys, gals, and non-binary pals. This is Unit 1, Chemistry Foundations. I'm going to go over scientific notation versus expanded notation right now. So I have an example here. I have 2.45 times 10 to the 4th power. This part right here, I'll go ahead and zoom in really quick, is your decimal portion. It's sometimes called your mantissa. Right, and so that's just the decimal portion of it. The times 10 to the nth power, that's going to be your exponential portion. It's sometimes called your inordinate, or your ordinate portion. Those are just the fancy terms for it. I'll probably just refer to them as decimal portion and exponential portion. Whenever we're looking at scientific notation, it's just a way to express really big numbers or really small numbers in a more convenient way instead of writing it out over and over again. And so we're going to go ahead and look at this one and turn it into expanded notation. So what do I mean by expanded notation? I realized I put an extra n in there, so expanded notation, there we go. It just means like a normal number, what you would typically expect, like 1 to infinity, right? And so if I have a positive, right, this is positive right here. If I have a positive exponent, and in this case it is positive 4, that means that my number is greater than 1. So this number, when I expand it, when I take it out of scientific notation, is going to be greater than 1. And so let's go ahead and do that over to the right-hand side. I'm going to go ahead and rewrite it. So 2.45 times 10 to the 4th. If I expand it, and I know that it's greater than 1, that means that this tells me how many times to move my decimal place. And I'm going to move my decimal place 4 times. And I know I'm going to move it to the right specifically because it's a positive exponent. So what does that look like? So we have the decimals here, so we're going to go 1, 2, 3, 4, right? And so it's going to end up, there's going to be some imaginary zeros that we're going to add here and here. So if I write it out, my new number expanded will be 24500, right? So the decimal was here and we went over 1, 2, 3, 4 times. So this number in scientific notation is 2.45 times 10 to the 4th, but the actual number is 24,500. So expanded notation is just a normal number like we're used to, but sometimes they get too big or too small, and so scientific notation is a convenient way to express it really quickly. All right, so let's go over some examples of putting a standard number into an expanded number into scientific notation. And so the first thing is we're going to identify where the decimal point is. So the decimal point is right here. And we want to move it, the decimal point, to where it's between two numbers. And the numbers should be between 1 and 9, right? So you want the numbers to be between 1 and 9. So it's the first time that the numbers are between 1 and 9. So we have 0, 0, and then 3, and then a 5. So the decimal needs to end up between these two numbers because that's the first two numbers where it's between a number 1 and 9. So we have 1, 2, 3. That's how many times we need to move our decimal place over. So 1, 2, 3. When we rewrite it, we're going to go ahead and write it as 3.5020 because we moved the decimal place in between the 3 and the 5. And then we add on the times 10 to the nth power, and the nth power is how many times we moved it. And again, if the exponent was negative, if it was less than 1, and it's positive if it's greater than 1. So if this number is less than 1, we put the exponent as negative. And so when we look at this number is much less than 1, right? 0.003520 is less than 1, and so this will be a negative exponent, and it's however many times we move the decimal. So 1, 2, 3, so it's going to be 3.5020 times 10 to the negative 3. Let's look at the next example. 350.20. We're going to move the decimal in between the first two non-zero numbers, so again the 3 and the 5. So this time they're on the left-hand side instead of on the right-hand side. And so we're going to go ahead and write 3.5 020 times 10. This time, this number, 350, is greater than 1. So it's going to be a positive exponent, and we went 1 2 times over. Let's look at the next one, 49.00. So the 4 and the 9, those are between the numbers 1 and 9. And the zeros, they are not between numbers 1 and 9. And so we're going to move this decimal over 1 time to the left. So we end up with 4.900. And then we add the times 10 to the nth. And this is a greater than 1 number, so 49 is greater than 1. So it's a positive exponent, and we moved it over 1 time, so it's just times 10 to the 1th, to the first. All right, this one, they didn't give us a decimal, so we have to locate it ourselves. So the decimal, if they never give it to you, just assume it's at the end, right? So just place the decimal right there. And this time we're going to go over 1, 2, 3, 4 times. And the reason why is because, again, we have to get in between a number that's non-zero, right? So 7 and 5 are non-zeros, so we need to place the decimal between those two right there. So we're going to go ahead and write 7.5 times 10 to the nth. Again, 75,000 is greater than 1. So it's a positive exponent, and we went over 1, 2, 3, 4 times, so it's times 10 to the 4th. Here I'm paying attention to significant figures, right? My trailing zeros are only significant if there was a decimal. Since there was no decimal, I added that imaginary decimal. There's only 1, 2 significant figures here. The next one down, the 5.2, the decimal's already in between the two non-zero numbers. We don't need to move it, so we can either rewrite it as 5.2 and we're done, or we can say 5.2 times 10 to the 0th, indicating that we didn't change anything. We didn't move the decimal. Let's see, the last two down here, we have 0.00168. So we're going to take our decimal, we're going to move it between that 1 and the 6. So we have 1, 2, 3 times over to the right. So we have 1.68. Add our times 10 to the nth. This number is smaller than 1, and so it's going to be a negative exponent. And we moved it over 1, 2, 3 times, so times 10 to the negative 3. The last one down here, we have 500. It's very similar to 75,000. There's no decimal place here, so we're going to add that imaginary decimal at the end of it, and we're going to move it over between the last non-zero number, which would be the 5, right? So we do 1, 2. So we just move it over 2 times. So we have 5 times 10 to the positive 2. It's positive because 500 is greater than 1. Let's go ahead and look at some examples where it's already in scientific notation and we have to take it out of scientific notation. So the first thing to kind of point out is the exponents at the very top, right? So we have a positive 3 for the first one. And so that means that that number was greater than 1. If that number is greater than 1, we need to move our decimal place to the right. Right? So if it's greater than 1, right, so the positive number, we're going to move our decimal place to the right. And so I'll go ahead and rewrite it down here. So we have 2.75, and we're going to move it decimal place right here to the right 1, 2, 3 times. So we have 1, 2, 3. And so when we rewrite this number, we end up with 275, add a 0 if you have to keep going past what they give you. So we have 2,750. Right, the next one is negative 2 as our exponent, so that means that the number was less than 1. If the number is less than 1, we need to move it to the left. So we're going to move our decimal 2 times to the left. So we have 5.143. We're going to take that decimal and we're going to move it to the left 2 times. 1, 2. The reason we move it to the left 2 times is because of the negative, and it says a 2 right there. So when we rewrite our number, we have 0.0, so add an imaginary 0 right here. 5143. So that's a number that's less than 1. The next one down, it's a positive 3 again, so we're going to go ahead and move it to the right because it's greater than 1. And so we have 1, 2, 3 to the right. Add our zeros in there. So we end up with 4200, so 4,200. 2.15 times 10 to the negative 4. Negative exponent means that the number was less than 1 originally, so we're going to move our decimal place to the left. So we have 2.15. We're going to move it to the left once, twice, 3 times, 4 times. And so we add some zeros in there as placeholders. And so when we rewrite this, we have 0.000215. The next one, we're going to go ahead and do that. Same thing, because it's a negative, so we're going to the left, but we're doing it 6 times. So we have 3.14. Move the decimal once, twice, 3 times, 4 times, 5 times, 6 times. Add in those zeros, so we have 1 0, 2 zeros, 3 zeros, 4 zeros, 5 zeros that we added in. So when we rewrite this number in expanded notation, we should write 1, 2, 3, 4, 5 zeros and follow it with 314. The next one down, it is a positive exponent, so that means that this number was greater than 1. So we're going to move that decimal over to the right-hand side this time. So we have 9.22. Our decimal, we're going to take it and move it over to the right 5 times. So 1, 2, 3, 4, 5. Add zeros in as placeholders, so it ends up being 922,000. So that's 922,000. And then the last example that I will show you is this bottom one. So 9.57 times 10 to the second. We have a positive exponent, so we're going to move it to the right because this number was greater than 1. And so we're going to take it and go 2 times to the right. So when you rewrite this as a normal number, it's 957. Right, the last thing I want to show you is your calculator. This is the brand of calculator that I currently have, so if you have a different calculator, you'll have to match it up to whatever you have. When you put in a scientific notation number, so say we're putting in the number that I started with at the beginning, so 2.45 times 10 to the 4th, you're going to go ahead and put 2.45, just like that. And there's a little button that says EE, and it's right next to the x to the negative 1, but it's in blue, so we have to press second and then that one. So it should pop up with E. That E stands for the times 10, right? So I'll go ahead and write that down. So you're going to go ahead and put it in whatever number you have. So in this case, it was 2.54. And then it's the second button. And then we click on the x to the negative 1 in this case, but you want to look for the big EE. And that EE stands for times 10. So all you have to do after that is whatever the exponent was. And so in this case, it was 4. So I'm going to go ahead and press 4. If I equal that out, it gives me the expanded notation. So 24,500 in this case. Right? I hope that helped. Ask me questions in class. Come to office hours. I'll see you guys later.